Hello and welcome to Physixify once again. Today we are going to talk about a very special topic called potential energy. Now, if you would see what exactly is this thing, this is what we call a trebuchet. What is it used to do? It is used to actually throw an object from one place somewhat over here to this side, something like this. Right. So this is one thing that was actually giving in, it requires a lot of potential energy from here to be converted and given to this and made sure that it gets all the kinetic energy possible. We have talked about kinetic energy earlier. Today we're talking about potential energy. You are with me, Udit Gupta, and let's see what we have for today. Now, if we talk about the theory in potential energy, we will say that the potential energy word is actually not defined, right? We cannot say simply that, okay, it has certain potential energy, this has certain potential energy. But what we are actually more concerned about is the fact that what is the change in potential energy, right? Change in potential energy is a much more elaborate, much more defined quantity that we would be using, and talking more about it, I would try to relate it with respect to a conservative force. How? We say that if we want to define potential energy, or maybe this change in potential energy, because that is what we define, we call this change in potential energy as delta U, which is the negative of work done by any conservative force, right? If you want to write it down in mathematical terms, you can say delta U is minus WC. Now this is the formula that you can sort of remember, and later on you can say delta, that means change, it means final minus initial, and you can relate it to minus WC. One point to be noted here is that potential energy will only be defined for a conservative force. If you see delta U as given to be minus WC, this automatically means that if there is a non-conservative force, you will not write any potential energy or change in potential energy, right? Okay, so let me tell you, if you talk about friction and normal reaction, these are non-conservative forces. There won't be any sort of potential energy defined for friction and normal reaction force. But if we talk the same about gravity force, elastic force, or electrostatic force for that matter, you will say all these three are going to be your conservative forces, and that's why you will define change in potential energy for these three forces. Moving on ahead, if I want to prove how exactly this formula turns up delta U equal to minus WC, I will try to do it like this, right? I want to prove that final potential energy minus initial equals this minus WC. This is the same statement as delta U equal to minus WC. So first thing that I do is I take a table, I take a block, and I say that, let us say from the ground it is at a distance h1, at a height h1 it lies from the ground. This is my initial case scenario. Now what I do is I take it up very slowly to a height h2. So I have gone from here to here, something like this, and let us say I've gone very slowly. Why am I going very slowly? So that my kinetic energy at any point is anda, is zero, right? Is nothing. Because if I take it very slowly, almost velocity is zero at all the points, then you can say that any energy that I have achieved or I have gained or I have gotten is actually potential energy. Now what I'll say is that normally we know that potential energy is mgh. So I can say that this final position will give me a potential energy mgh2, while this initial position will give me a potential energy mgh1. If I want to do uf minus ui, I can simply get mg times h2 minus h1. And if I talk about now the conservative force, so I will see that I have a force mg that acts in the downward direction, and we are having a displacement s in the upward direction. that is h2 minus h1, because if total height was h2 from the ground, h1 over here in the initial case, this remaining one happens to be h2 minus h1. So now I can write down the work done by this gravity force, work done by my conservative force, that is gravity here. If I do F dot S, I will get mg into h2 minus h1, mg on the downward side, h2 minus h1 on the upward side, and that is why the angle is 180 degree. Mg into h2 minus h1 into cos 180. So you'll get this work done conservative as minus mg times h2 minus h1, and I think your work is done now. You can say uf minus uc turns out to be minus wc, so we can say hence proved, right? So this is done deal. I hope you have understood. This was the proof of potential energy. Let's proceed a little further and let's talk about what would be your steps to solve any question that you get in potential energy. So the steps are very easy. This is going to be the most important thing for you that you can take down from this video. In the next one, we will be doing questions on these. So let's see what are the steps. First step, you write down the definition of potential energy, that is delta U equal to minus WC. Next thing that you can say is, if you put it in differential form, you'll get du equal to minus dWc. Next point is that if you integrate it on both the sides by putting the proper limits, you can actually get something, because you know that dWc can be written as f dx or basically f c dx. Why am I writing f c over here? What is the purpose of writing f c? You relate it to potential energy and you say only conservative force can actually be coming here if you have to talk about potential energy. So this is the final formula that you can remember. We'll be using that in the upcoming videos. I hope you would be ready to see some questions. This is me saying thanks for now, and if you had any queries, do drop it in the comment section. The links for Instagram, Facebook and Twitter are in the bio, so you can join us over there as well. Do not forget to like and subscribe if you actually like this video. This is me saying bye bye for now. We'll meet back again with some questions.